two separate videos, we have covered combining like terms and the distributive property. With this video, we are going to combine both as we work to simplify algebraic expressions by combining like terms and also using the distributive property. The best way to look at this is by working through a few examples. Now, I'm not going to have anything super creative this time, but let's start with this example. Our goal is to simplify this expression. Now remember, to simplify, we are trying to condense the expression down to the least amount of terms possible, so it looks the simplest. That's why it's called simplify. When I see expressions like this, my first thought is, how do I get rid of the parentheses? Because without getting rid of the parentheses, I am unable to simplify by combining like terms. So I have to get rid of the parentheses so I can combine like terms. I know that the distributive property will be useful in this scenario because I have a factor of 3 directly touching parentheses. This tells me that the 3 will have to be distributed through multiplication to each term, in this case the 2 terms inside of the parentheses. When I distribute the 3 properly, I end up with 15 plus 3x. So my new equivalent expression following the distribution is 15 plus 3x plus 4x plus 2. Notice the parentheses went away towards the left side of our expression following the distribution. But on the right side of our expression, 4x plus 2 is currently nested inside parentheses. But the 4x plus 2 is simply being added to the rest of the expression. And we know in mathematics we can add terms in any order, and it doesn't affect the sum, it's not going to affect the answer. Therefore, I'm going to drop the parentheses on the 4x plus 2. Once again, I can only do this because what is inside the parentheses is simply being added. And the order you add does not make a difference. Now, I am going to move around the terms to put like terms next to each other. This isn't 100% necessary, by the way, but it may help you get a clearer picture of what can be combined. In this case, I'm simply going to move the constant of positive 15 to the end of the expression. Now I have the expression 3x plus 4x plus 2 plus 15. I want to reiterate that every expression on the chalkboard right now are all equivalent to each other. We're using mathematical properties to create these equivalent expressions with our ultimate goal of finding the most simplified version of the expression. We are able to make an additional step here. We're not done because we can combine like terms. 3x and 4x combines to make 7x, and our constants 2 and 15 combine together to make 17. So our final simplified expression is 7x plus 17. And we cannot simplify that any further because 7x and 17 are not like terms. As a brief reminder, before we move forward, feel free at any point to rewind or pause the video at your discretion. This is one of the benefits that you guys do get from learning virtually. Please work at your own pace. Now we're going to move on to this next example to help hone our skills in a little bit more. I immediately notice parentheses, so I'm already anticipating the fact I'm going to use the distributive property. The negative 5h and 3 cannot be combined because they're not like terms, so the only way to get rid of these parentheses is by distributing the negative 4 to both of these terms. Notice I said distribute negative 4, not 4. You have to always carry the symbol, the positive or negative, the plus or minus, that is in front of values in mathematics. So it's important. You will continually mess up the distributive property if you do not take the symbol in front of the number. In this case, it was a negative. So once I distribute the negative 4 using my integer rules correctly, I end up with 2, a positive 20h, and negative 12. The negative 4 times the negative 5h results in a positive 20h. Whereas on the other hand, when you multiply by different signs, the negative 4 and the positive 3, we ended up with a product of negative 12. Now, we are not done here because we have two constants that can be combined, because constants are always like terms. 2 in the negative 12, so either 2 plus negative 12 or 2 minus 12, equals negative 10. Therefore, our final simplified expression is 20h minus 10. This can also be written as negative 10 plus 20h if you prefer, since the 10 remains negative while the 20h remains positive. Final example, we are going to revisit distribution of a variable term, meaning the term you're going to multiply to everything inside the parentheses is going to be a variable. Here, we are going to have to distribute an x to both 5x and negative 2. The x is not distributed to the x squared or negative 9, as they don't belong within the same set of parentheses. So just keep that in mind. When we distribute the x, we end up with 5x squared, a negative 2x. The x squared component comes from x times x. So when you distribute that x, you have 5x times x, and that x times x gets that x squared. Now look at our expression. We have 5x squared minus 2x, or negative 2x, plus x squared minus 9, or negative 9. Once again, we can add in any order, so we can drop the parentheses around the final two terms in this expression. This leaves us with the following expression. Now there are some terms that are alike still, and thus can be combined. 5x squared and x squared are like terms because they have the same variable and the same exponent. 5x squared plus another x squared results in 6x squared. After we have combined those two terms, there are no like terms remaining. Negative 9 is the only constant, and negative 2x is not raised to the same power. It's not raised to the second power. It's technically only raised to the first power, but you don't need to write it. Therefore, it cannot be combined with the 6x squared. So we are finished, and we have created a simplified equivalent expression by combining like terms and using the distributive property. With the third and final example in the books, we have wrapped up the last Mr. Jackson created video on expressions for week 1 of this summer prep course. By Friday, prior to taking your Edulastic post quiz, you should be an expert on combining like terms and using the distributive property to simplify algebraic expressions. Make sure you continue to practice by accessing the resources that are inside your flowchart. The more you practice, the better position you'll be in. Imagine Math is also a great tool to practice your foundational algebra skills, so utilize that as well. And keep working hard, and as always, reach out for support as needed.